everybody. First of all, I want to thank everybody for being here, and I want to thank you too for this summer school. This is a great experience for us. So I want to present you the results of our team, of the work being done for the last 3 days. The topic of our project was the same as the previous team, and I want to say a few words about the problem we wanted to solve. Imagine the person working in a grocery store. Usually people are searching for something and they pay more attention to particular products over other products, and it would be really great if you can capture somehow the direction of in which they are looking. So, for instance, we can use the top view cameras to do that. So, as you can imagine, this is a huge scope. The project itself, the problem is very complex, and so given 3 days and given 5 people on the team, given some data and given the best supervisor of the research, what we wanted to do, first of all, we wanted to build a proof of concept to prove that this problem is solvable. And while doing that, we wanted to try different computer vision techniques that we learned during the summer school, and basically to learn something. So the first question you ask yourself when you do any kind of machine learning, the data set. So we got 2 data sets. Each of them has its own incompletenesses. Like first has depth camera views without colored views, like on the pictures above, but it has labeled joints, and another one has depth and colored views, but it has no labels to grade on. And we wanted to put this picture because it kind of characterizes the role that our team made during these 3 days, like taking different approaches, approaching from different sides, going from more classical computer vision techniques to more deep learning, pure deep learning techniques, going from existing level data set to labeling data set by ourselves. So first of the approaches we tried was using mostly classical computer vision, using OpenCV with background subtraction and using this library. By the way, can we play the video right now?
It's PDF.
Yeah, just okay. So this approach, this is a real time. This approach works in real time, so it has a nice performance, but it lacks quality, as you can see here. So overall, it really depends on lighting and environment, and still we have the problem of detecting the direction itself. Yeah, okay, you can close it because it takes more than 1 minute. So here is the summary, technical summary of the approach we took. Another approach we took was using TensorFlow Object Detection API. We used pre-trained SSD MobileNet model. We prepared the data set of 250 images, and this gave us really relatively good quality of detecting heads of people. We're from 60 to 80–90% of detection quality. And the third approach we tried was head segmentation with UNet. So we retrieved masks from depth pictures, and we trained on the colored images on one of the data sets, but as you can see, the result was not as good as we expected. So the conclusion was there is not enough data. So then we listened to our mentor. We need more data on the set. And what we did next, we spent 3 days, 3 nights working on data sets. Okay, I'm joking, we spent only 1 evening, but we prepared 1 data set, not very big, but combining it with our object detection API, which could detect people's heads then going through the CNN regression to detect the direction itself, and putting this together, you could visualize the direction itself. So here it is. As you can see, the red gradient here. You can imagine the grocery store shelves, basically, and people staring there. So there are a few examples. This is not a real-time solution. The performance is almost 2 frames per second. And there are various quality issues with that. For instance, on this one, you can see there are no heads there. And on these two, this is actually a common problem, being able to detect the head itself and detect the direction of the head. It's often it's hard to tell where exactly person is looking, whether forward or backward, because the head, the shape of the head is elliptic, so that's a problem. So a quick summary on technologies. This is a common data science stack. Basically, we use Python 3, OpenCV. We use Google Cloud Platform for training on GPUs provided. We used a couple of pre-trained models. Yeah, so the summary and lessons learned. The biggest lesson, in our opinion, is the data set is a key to success. With the more data you have, the better result is, of course. And without having enough data, using just a classical computer vision, for instance, it's usually not enough. But we can use it in some cases to improve quality, to have improved performance in some cases. And overall, we need much more optimizations for making this a real-time solution, of course. Yeah, where we can go next? We can prepare more data. We can try different approaches. We can try segmentation of the whole body instead of the head only. We can use more classical computer vision for preprocessing data. And yeah, we can add more cameras to capture video from different angles. And of course, tune hyperparameters and try different models. So thank you. This is our team. We are very appreciated to be a part of this summer school. Thank you.
Thank you guys, and it's time to give you certificates.
So, after, thank you very much, Andrei.